Okay, so now we want to talk about number, let me check, 5. Two blocks of mass 300 grams and 200 grams are moving toward each other along a horizontal frictionless surface with velocities of 50 and 100 centimeters per second respectively. So if I drew that, I would have the 300 gram, which is 0.300 kilograms. I'm going to call that M1. It's moving to the right at 50 centimeters per second, which is 0.5 meters per second. Mass 2 is the one that is 200 grams, which is 0.2 kilograms. It's moving to the left at 1 meter per second. And I'm going to make that be a negative 1 because I want to remember that it's going to the left. And if they collide and stick together, find the magnitude and direction of their resultant velocity. So part A is m1v1, m2v2 equals m1 plus m2, because they're stuck together, v prime. So I have 0.3 kilograms times 0.5 meters per second plus 0.2 kilograms times a negative 1 meter per second is equal to 0.5 kilograms, because that's the sum of the two together, v prime. So half of 0.3 is 0.15. Negative 0.2 is equal to 0.5 kilograms times v prime. So this minus from this, or positive 0.15 minus 0.2 is going to be a negative 0.05 kilogram meters per second. Going to divide that by 0.5 kilograms, a half a kilogram, to give me v prime. So 0.05 divided by a half is the same thing as 0.05 times 2, and that gives me negative 0.10 meters per second is equal to v prime. So the group is connected and they are being moved to the left. Okay, part B says, what is the kinetic energy of each block before and after their collision? Okay, so I want to go to the red. I'm going to come over here. I'm going to do block 1 first. KE initial is 1/2 m v squared. Well, 0.5 squared is 0.25. 0.25 times 0.3 is 0.075. And half of 0.07 is 0.075 is 0.0375 joules. So that's the KE initial. KE final is equal to 1/2. M is still 0.3. B is 0.1. And it's negative, which really doesn't matter because I'm going to square it anyway. 0.1 squared is 0.01 times 0.01 times 0.3 is 0.003. Half of 0.003 is 0.0015 joules. KE final. Okay, so I'm going to pause for a minute and check my math. Okay, so my math seemed fine. Now I want to do block 2. KEI is 1/2. M is 0.2. B squared, let me go back and check that since I can't see anymore, 1 meter per second. So 1/2 of 0.2 is 0.1. So 0.1 times 1 squared is just 0.1. So the KE initial was 0.1 joules for block 2. And then final KE, 1/2. M is still 0.2 kilograms. And the speed is negative 0.1. Don't forget to square that, so I get 0.01. 0.01 times 0.2 is 0.002. Half of 0.002 is 0.001. And you can see that momentum or kinetic energy is not conserved, because I had 0.1375 before, and now I have, after I have 0.0015 plus 0.001, which is 0.0025. So I've lost some kinetic energy. Alright, let's go on to number 6. Suppose you had a mass of 80 kilograms. How fast would you have to run to have the same linear momentum as a 1,600 kilogram car moving at 1.2 kilometers per hour? So that's the mass of you. Mass of the car is 1,600 kilograms, so it's 20 times greater than you. And the car is moving at 1.2 kilometers per hour. So you are 80 kilograms with some speed, we'll just call V1. And you have to equal the momentum of this vehicle. So I just said, well, this is 80. This is 1,600, so that's 20 times as great. 20 times 1.2 is 24 kilometers per hour. That's how fast you would have to run to have the same momentum as the vehicle. All right. Number 7. Number 7 says a force that averages 1,200 newtons. So my force is 1,200 newtons. Is applied to a 0.4 kilogram steel ball. The initial speed of the steel ball is 14 meters per second. The time of the force's application is 27 milliseconds, and that is 27 milliseconds, which is 27 times 10 to the minus 3, or 0.027, same thing. And they want to know what is the final speed and direction of the ball. Now, they tell you that the force is applied in a direction opposite the original motion. If I go back and read that correctly. Yes, in a direction opposite to the, okay, so we're going to make this be a negative 1,200. So F delta T equals M delta V. So negative 1,200 times 0.027 seconds divided by the mass of 0.4 kilograms is equal to delta V. So I'm going to solve for delta V first, and then I'll go back and find VF. So if I turn on my trusty little iPad to use a calculator, I have negative 1,200. Oh, didn't like it. Here we go, negative 1,200 times 0.027 seconds gave me negative 32.4, and I'm going to divide that by 0.4 is negative 81. So the change in velocity is a negative 81. So delta V is equal to negative 81 meters per second. So VF minus VI equals delta V. VF minus 14 is equal to negative 81. So VF is equal to negative 81 plus 14. So VF is going to be a negative 67 meters per second. So now it's moving to the left at 67 meters per second. All right, number 8. Okay, we'll do number 8, and then we'll pause it and save it, and then I'll do 9, 10, and 11. Okay, so you have a block of wood resting on a tabletop. It has a mass of 3 kilograms. Not moving at all. Rest on the muzzle of muzzle opening of a vertically oriented rifle, the stock of the rifle being firmly planted on the ground. So there is the rifle barrel right here, That's a pitiful rifle barrel. And then there's a gun down here. Gun. And here's the ground. Alright, so that's what I know. I'm going to fire the rifle. A bullet of 8.5 grams comes out at 700 meters per second, going straight up. And the mass is 8.5 grams, which is 0.0085 kilograms. And they want to know, and it's going to be completely embedded in the block, so it's not even going to get out of there. So it's going to come over here. It's going to come like that. That's just going to be its VI. Its VF will be 0 because it's stopped in the block of wood. And they want to know, using momentum, conservation linear momentum, find the velocity of the bullet block system. Alright, so I have M1V1, M2V2 equals M1V1 prime. I'm sorry, M1 plus M2, because now they're stuck together. V prime. Okay, so let me think about what I want to do here. I know that my mass 1 is the block. It's not moving at all. And M2 is the bullet, moving at 750 meters per second, or 700 meters per second. And now the bullet and the block are stuck together, 3.0085 kilograms. And they have a common velocity that I'm going to call V prime. So that quantity I don't have to care about. So I'm going to multiply 700 by 0.0085. So 700 times 0.0085 tells me that the momentum of that system is 5.95. 5.95 kilogram meters per second divided by 3.0085 kilograms. That's my V prime. So 5.95 divided by 3.0085 gives me 1.98 meters per second. And I think there's a part B to number 8. Part B says, ignoring air resistance, how high does the bullet block system rise above the muzzle of the rifle? So I'm going to use conservation of energy. I'm going to say that the KE of the bullet block system is equal to the PE at the highest point. So I'm going to have, and I could call this PEI, but it's 0 because I picked it that way. PEF plus KEF. It comes to a stop because gravity slows it down. So I have 1/2 mvi squared equals mgh. The mass is the same because it's the bullet and the block. So I have 1/2 1.98 meters per second squared is equal to 9.8 meters per second squared times h. So if I square my 1.98 and divide that by 2, and then divide that by gravity, I get about 0.20, 20 centimeters. H is about 0.20 meters. So there's that one for part B, and there's part A. I'm going to save this one, and then I'm going to record a new one.